Okay, welcome to part 2 of our tutorial of project number 1 for our BL460 class. Remember, in the last video I showed you how to obtain tree ring measurements by downloading them from the ITRDB. And then in this video what I'm going to show you is how to verify the accuracy of the cross dating using a program called COFECHA. Now, if you downloaded measurements from the ITRDB, they're probably going to be pretty good and quality controlled, but you really should check before moving forward and developing a chronology. So we're going to use COFECHA. I'll show you how to do that. Okay, so in the last video we downloaded COFECHA, and I have COFECHA and I have my measurement files all in my BL460 folder. So I'm just going to double click on COFECHA and run it. So here we go. Make this window bigger. Okay, so you can identify the job. It'll ask you for a little title here, but you don't have to worry about it. You can just hit enter and move on. Okay, so the cross-dated tree ring series. So this is the file name of your measurements. So mine is CO580.rwl. Okay, and it should show you the first 8 lines to make sure that's correct, and the format is measurements. So the default here is yes. You can see the Y is in brackets. So you can just hit enter, or you can hit Y and then enter. Okay, then it asks you for an undated tree ring series. This is if you had a log or a piece of dead wood and you didn't know when it died, and you just wanted to run those measurements against an already dated series to see if there's any matches. But we're not doing that, so we're going to just hit enter and move on. So a title for this run, so I'm just going to name it CO580 and hit enter. Okay, now here are all the sort of settings that you can manipulate before running COFECHA. We're going to leave all the defaults here for our purposes, but the main one that you might want to change when doing this is number 2, so the segment length to examine. Basically what COFECHA does is it takes each core in COFECHA is called a series, so it's a measurement series. And what it's going to do is it's going to split it into segments, and then it's going to run correlation coefficients between each segment of each core and all the rest of the cores in your measurement file. So basically you can manipulate how big of a segment it's going to use. The default here is 50 years lagged 25. So that means you'll have overlapping segments of 50 years that it's going to run correlations on. And that's a pretty good place to start, so we're going to leave that the way it is. So I'm going to hit enter to proceed, and it's going to run all those correlations, and it's done. Okay, so we'll just hit, and we can see that the file to print here, the default name is zzcof.out. So that's your output file. So I'm going to go ahead and close this. Save changes, no. And so here's our output file in the window here, so zzcof.out. If I gave it a job title in that first setting, it would change the file name, but I'm just going to use the default zz. Okay, so I double click on this to open it up, and here's my results. So the top part just sort of gives you the sort of background information on what you ran. So the title of the run, the series, so CO580.rwl is the file that I ran. It has the date and the time and all that kind of stuff up here. And then it has all the settings that you chose. So I chose all the defaults, so I'm going to leave that alone. Okay, then here's the basic summary. So the number of dated series, so there's 25 series. They span from 1382 to 2000 AD. The total number of rings checked, the average intercorrelation. So I'll explain what that is in a minute. Okay, the next part, so here we see part 2. This is all the sample numbers. So remember, this is my I downloaded a file from Land's End. So all these have a sample number LAN. So LAN 072, LAN 111, and so on. it shows you the time span, so 1850 to 2000 in the case of this one, and the number of years. And then over here is a depiction of your sample size over time, right? So from stretching back from 2000, these little lines indicate the years covered by that individual series, that individual core. So you can see your sample depth and where you have overlap over time. Part 3, what this is it shows every year, it shows a standard deviation value, and then it shows the sample depth. So for instance, in the year 1400, my standard deviation is 1.306 and it's positive. So that means this, this year is 1.3 standard deviations wider than the average ring width within a window around that year. And then I've got 4 samples that go back to that year. Okay, if I look at a more recent year down here, so for instance, here, 1977, I've got 22 samples. This is in 1977, and it's negative 2.377 standard deviations, narrower than the average ring width in this general region. So this is a pretty narrow ring, right? More than 2 standard deviations narrow. So basically this kind of shows you the pattern of narrow and wide rings in your file. Part 4, this is the bar plot. This is basically the same thing as the last one, except it's just a graphical depiction. So in this case, letters are standard deviations. They're actually quarter standard deviations. So the @ sign means that that year is average for that part of the core. And then capital letters are wider and lowercase letters are narrower than average. And each letter is a quarter standard deviation. So in a lowercase a in this year means that 1976 is 0.25 standard deviations narrower. A capital D means 1975 is 1.0 standard deviations wider. These are handy if you're working on a chronology, you're measuring cores and visually cross-dating. If you already have some cores cross-dated, you can print this bar plot out and tack it up on the wall next to your microscope, and you can kind of double check as you're working on new specimens to see if you're visually cross-dating correctly. Okay, now part 5, this is kind of the most important part of the output. So this is your segments, so those 50-year segments, and the correlation coefficients between them. I'm going to scroll down here, so I'm looking at the most recent segments. So for instance, we see, we've got a segment 1999 back to 1950. And so for this sample, I have a 0.61 correlation coefficient for sample LAN072. So what that means is, for these years, for 1950 to 1999, COFECHA took just this core, and it ran the correlation between this core and all the rest of the cores in the file. And it said, what's the correlation between those? And the correlation is 0.61. So a pretty good correlation. And then you'll notice that the segment right before it is 1925 to 1974. So those segments overlap by 25 years. 50-year segments overlap by 25 years. Anyway, so that's what's going on there. You have those correlation coefficients. Now, there's a couple of things to keep in mind. And COFECHA will give you flags, so an A flag or a B flag, if those correlations aren't sufficient. So I can look over here, I can look down here on sample number LAN151 for this 1875 to 1924 segment. My correlation coefficient is 0.29 and I've got a little A flag there. What the A flag means is that with a 50-year segment, to have a significant correlation at a 0.05 p-value, you need a correlation of 0.3281 or higher, and so 0.25 is a little low. Now that's not always a big deal, but you'll see those flags if there's a low correlation. The other kind of flag is a B flag, and that means COFECHA found a higher correlation somewhere else. So here's an LAN162, and we can see a B flag right here. So in the 1900 to 1949 segment, the correlation's 0.31, which is low, and there's a B flag, so they found a higher correlation somewhere else. Now, again, that's not always a big problem, but it can be. For instance, if you have a whole bunch of segments, consecutive segments that are B flagged, and then you look and the higher correlation is maybe a +1 or a -1, maybe you have an extra ring you measured wrong, or you have a missing ring. And if you make that shift, everything else falls into place. Here this doesn't look so bad because look at the correlations before and after. I have a 0.58, which is significant before it, and I have 0.51, 0.73, 0.72 after it. So this one little outlier is probably, it doesn't mean it's incorrectly dated, it just means it's a low correlation. Okay, so we can inspect this a little farther. So let's see, this is series number 14, LAN162. So if I scroll down to the next section of the output, I can go into these in a little more detail. So I'm looking for series 14. So here it is, series 14, and this is LAN162. So here's our problem segment. 1900 to 1949, it has a flag. So in the 0 position, as dated, the correlation is 0.31. Now COFECHA, it shifts. It says, what would the correlation be if you shifted this segment forward in time and back in time? So we can see +1 years, 2 years, 3 years, out to +10 years, and -1, -2, -3, out to -10 years. And so then it puts a little asterisk at the highest correlation. So we see the highest correlation here is 0.35, and it's at the -10 position. So if we were to shift this back from 1900 to 1949, if we made it 1890 to 1939, it would have a slightly higher correlation. So what this looks like is that it's probably correctly dated. It's unlikely that there'd be 10 missing years here, and even so, that correlation is just marginally higher, 0.31 to 0.35. So this is exactly the kind of thing, you know, a flag doesn't mean that it's wrong. It could just be that that tree is not correlating well with the other trees in the series at that time. You can imagine a tree might have gotten injured or something, and is recovering from injury, so it's not going to be growing in the same exact pattern as other trees. So what you'll want to do is scan your output, look for flags. The key thing is if you have a whole bunch of segments in a row with flags, that might be an error. If you have 1 or 2 isolated flags and the segments before and after them are okay, then it's probably correctly dated. It's difficult because it's not our data that we worked on, but if it's somebody else's. But still, this will give you an idea. And like I said, if you downloaded your measurements from the ITRDB, they're probably going to be okay because they're usually quality controlled. But you have to check. There can be problematic data uploaded there. Okay, so that part is exploring those series in detail. And then the last part at the very bottom is just your summary descriptive statistics. So it has each series, the interval, the number of years, the number of segments, the number of flags. So we see most of these have 0 flags. That's good. And then the total correlation. So if we take the whole core and correlate it with all the other cores, what's the correlation coefficient? And so 0.7, 0.7, 0.6. Those look pretty good. And then the overall, the average correlation is 0.63. Now, what's a good correlation? That's hard to say. It's going to depend on the species, and it's going to depend on the location. If you've got, ponderosa pine in the southwest, 0.7, 0.8 is going to be a good correlation. If you've got a mixed species stand with high density in eastern North America, maybe 0.4, 0.5, 0.6 would be okay. So you really have to know your system. But anyway, this is the next step. Look for flags. look at your correlations and make sure that your data look good to move on with further analysis. If you want to know anything else about COFECHA, this paper by Henry Gracino Mayer, Tree Ring Research, Volume 57 from 2001, it has absolutely everything you'd ever want to know about COFECHA. So you can find this paper and look it up, and it'll explain all the output. So that's quality control and cross-dating accuracy. In the next video, I'll show you how we standardize our cores to put them into a single tree ring chronology. So you'll go from multiple series or multiple cores and their measurements, and we'll go to one tree ring chronology. Okay, so stay tuned for that.